Hello and welcome, everyone. You are logged into the Fighting Flicker, the Impact of Flicker in Lighting webinar. Just a couple of house rules before beginning. This webinar is being recorded. Therefore, you will receive a recording at the end of this webinar in a follow-up email, and it will also be made available to you via Energy Focus. Everyone is in listen-only mode. Therefore, the best way to communicate with us is via the chat box, which is located on the bottom corner of your screen. When you send a chat, the speakers in this call are the only ones to see them, and we will respond directly to you. There will also be a Q&A section towards the end of this webinar where the most common topical questions will be presented. So please feel free to utilize this chat starting now and at any point during the webinar. This webinar is sponsored and presented by Energy Focus. Energy Focus is based out of Solon, Ohio. We engineer, manufacture, and sell LED lighting retrofit technologies for a range of applications listed here on this slide, where some customers include St. John's University in New York, the U.S. Navy, Delta Systems here in Ohio, just to name a few. From Energy Focus, we have two key speakers. The first is Laszlo Takacs. Laszlo has designed a wide variety of optical and electro-optical control hardware and firmware in support of the lighting industry since 1996. In 2011, he designed the first microprocessor-controlled intelligent lighting for Energy Focus's advanced fluorescent replacement lamps, which can analyze their control environment and act accordingly. He is also the architect of Sora's flicker-free MR16 electronics package, which is the most highly miniaturized and efficient flicker-free MR16 driver on the market. Laszlo currently serves Energy Focus as the company's Chief Technology Officer. Our second key speaker is John Davenport. John is a recognized global expert in light source physics and product technology. Starting his career at GE Lighting as a research scientist, John developed numerous advanced lighting products for GE, including what some of us know about is the blue xenon headlights that are currently used in cars. Over the past 18 years with Energy Focus, John has led the development of a range of LED lighting products, including the IntelliTube, which is Energy Focus's unique tubular LED retrofit technology. He is the author of more than 125 patents. He currently serves Energy Focus as the company's chief scientist. And my name is Yumi Alanoli, and I serve as the product manager in Energy Focus's marketing department. And with over 10 years of experience in the energy efficiency industry, I've seen the option for efficiency grow exponentially. One action that stands out throughout the industry is the power to understand and communicate top customer pain points via knowledge-based conversations, just like the one we're having today. Throughout this webinar, I will include a couple of poll questions just to kind of get to know the audience better. You know more about us, so let's get to know more about you. The first question that you should see on your screen is what applications are you looking to eliminate flicker in? And what you can do is you can go ahead and click on any of the options that you see on your screen. When you do click on this screen, you will be sent to the results section. I will give this about 30 seconds just so everyone feels comfortable using the poll options. And I do see responses coming in. Okay, I'll give it another couple of seconds here. Again, the question here is what applications are you looking to eliminate flicker in? Okay, I'm going to close this poll, and we can now take a look at some of the responses and the results. And as you can see, wow, almost all the above is predominant response from the audience in this webinar. Office spaces is the second highest with 21%. Healthcare, residential, industrial manufacture being the third, and the last education. Thank you so much for responding to this poll. I do have a follow-up poll, and the same idea follows. What type of lighting are you currently using? Please go ahead and choose one of the options that you see there. I'll give this another couple of seconds as well. And I do see responses coming in. And I do have to note, I do see a lot of responses coming in via the chat box. That's an excellent way to enter your response. But I would highly recommend pressing any of the radio buttons that are on this actual slide. So I'll give it another couple of seconds for you to respond to the actual poll here that you see on the slide. And I'm going to close the poll right now. And after that, we should all see that, wow, over 76% of us are using LEDs. And there is 20% of us that are using fluorescents, and a very small percent that don't know, which is just a great sign for me. So thank you very much for participating in these polls. Again, we will have a couple more polls throughout this webinar, but the response of the polls is very encouraging. We will predominantly talk about LED lighting in this webinar, so the idea of flicker in LED lighting will be discussed, but we will also talk about conventional lighting like the fluorescence and incandescence in HIDs. What I'm going to do is I will go ahead and click on this next slide. So hopefully everyone is all set with the polls. And without further ado, I will have Laszlo Takacs go ahead and kick off this webinar. Laszlo, the virtual microphone is all yours.
Thanks, Yumi. The topic today, of course, is flicker, and so some people might actually not know what that is. So I'll just start off a little bit talking about what exactly is the kind of flicker we're talking about today. And what it isn't is the kind of flicker that would immediately catch your eye and that you would spot as something that's irregular. It's not that kind of flicker. The kind of flicker we're talking about here today is a steady, systematic, very fast flicker that almost evades your vision. Not quite, but for the most part is not immediately noticeable. And it's the kind of flicker that's caused by fluctuations from the power line, making it all the way through the electronics and to the LEDs. So the LEDs are being driven by rippling power, again, related to the power line. So around most of the world, most of the flicker will be either 100 hertz or 120 hertz. And again, it has nothing to do with the light malfunctioning. It's the kind of flicker that's there by design. So lighting actually has a profound effect on cognition, and it's not generally well known, but a majority of the electrical activity in the brain is stimulated or related to vision, and about half of the brain is dedicated to processing vision. And so what this means is stimulations that come in that are, in some sense, unnatural, and flicker isn't really natural. It's the result of a technological stimulation. This kind of stimulation has the potential and the capability to affect a large part of the brain, but not necessarily in a way where you're immediately aware of it. Some of the other ways that lighting can affect us physiologically, and this is becoming better and better known, is it can affect and regulate your circadian rhythms, typically blue light. And a variety of hormones can be suppressed or activated depending on the kind of light that's there. And psychologically, this can have an effect on your mood, emotions, or your cognitive behavior. And different people can be sensitive to this to different degrees. We have a diagram here, a little diagram of the eye. I think most of us are fairly familiar with how this works. But the key thing to note here is that the eye is basically a large neurological receptor, which has detectors that are not only connected with vision, but also have these circadian receptors. And so anything, any kind of light, whether it's a spectral variation or a temporal variation like the flicker, goes straight into the brain through the eye, through the lens of the eye. So energy focus is basically dedicated to producing the highest possible quality of light. In particular, we've made the technical and really strategic decision to eliminate it to the best of our ability in our products. And the reason for that is because it is something that is technically feasible, but it's not something that's really on the radar of most lighting manufacturers, although the design community and others are fairly well aware of it. So to demonstrate exactly what I'm talking about here with Flickr, we've created this video. John, why don't you step in a little bit since you were heavily involved in manufacturing this or recording this data set and analyzing. Sure. Tell us what we're about to see.
Sure, I'll be glad to. First of all, the three lamps that you see on this slide would look to the eye as all the same. The light output would look steady. And what we've done, even though the light output is changing, flicker is a modulation of the light output. It can go all the way to zero. If you look at the reference on the web, you can actually see 6 different lamps. We're only going to show 3, one with very low flicker, which we produced by design, and then a couple of typical lamps to give you an idea. Now, what we've done is very simple. We've slowed down, if I go to the next slide, we've actually slowed down the movie so that you can actually readily see the variation in light output. So you can see it blinking on and off. Actually, that looks completely steady to the eye. The middle one has about 70% modulation. The one on the far right is about 35 or so % modulation. You can see it very readily. The range goes on the web videos 20 to about 70%, and all of them are readily visible. The only one that isn't, of course, is when you're less than 1%, which basically is at the limit of measurement, really. So you can do this yourself if you're interested in knowing whether or not a lamp is flickering by simply using the slow-mo video function on your phone. You take a clip that's in the slow motion. You can play it back, and you can actually see the lamp flicker. So I'm going to turn it back to you, Laz.
Thanks, John. And as a side note, when you showed me how you did that on the phone, I actually made a measurement here in the office that I'm sitting in, and I've got substantial flickers. So if I lose my way during this webinar, I'm going to blame it on the flicker. Okay, so this is actually flicker as a phenomenon has actually come to the attention of several of the standards bodies, including the IEEE and the IES. And if the flicker is severe, that is, if the percentage of flicker is deep, near 100%, meaning that the light is full on and goes all the way to full off, then it actually can have a severe effect on the people under the light, in the sense that it can, in the worst case, It can encourage things like epileptic seizures, headaches, fatigue, blurred vision, eye strain. And, some of these things may not, some of these effects may not become immediately apparent to the person sitting under the light. They may take time. There are some aspects of it that are immediately apparent, particularly when there are things moving around. If you're slicing carrots in the kitchen or something and you have high flicker, it's immediately apparent. But the effect that it has on you, on your well-being is something that grows as you sit under the light and can start in a subtle way, and then all of a sudden you realize that although you don't know why, that you may be distracted or you feel a headache coming on and so on. I've personally experienced this under high flicker lighting, and so I know exactly how that works. And an important point to realize is that the presence of flicker isn't really correlated with the quality of the lighting. Here's an example of a high-end hotel with very nice fixturing and professionally done lighting, but you go in there and measure the flicker, and it's near 100%. And the reason for that is the main reason is because flicker isn't typically marked or often it's not. Usually it's not specified, but typically it isn't part of the specification sheet for a lighting product. So and there's a cost impact in manufacturing. So often, even in a high-end facility, you will end up with a situation where a cost optimization during construction can end up with a facility that's got high flicker. It's not always the case. Eliminating flicker or even reducing it doesn't necessarily cost a lot of money, but like I said, it's not often known to the specifiers that that's there.
So Laszlo, I actually took that picture and stayed in that hotel room, and it turns out that all of the lighting, except for one bulb in the corner, not seen here, which was a fluorescent bulb, was at 100% flicker. And it was uncomfortable. I knew that something was wrong, and the reason I had this flicker meter with me and was able to measure it was I was giving a talk. I was supposed to give a talk for educators at the conference center in Pasadena, and I happened to have the equipment with me, but I didn't need it. You could tell you felt uncomfortable just being in that light. I had to turn off all the lights and just use the single fluorescent, which really wasn't as bad. It was about 30% flicker. It was much better than this 100%. So this is a real thing. It's a real case.
Yeah, it really is.
Add that.
Yeah, I appreciate that, John. I've experienced this myself also. I don't have a flicker meter like this with me when I typically travel. I might get one. And I'll mention for the audience, there's two really good ways to measure this. One is with a detector of the kind John has here. The other is in the form of an audio detector. So if you take a speaker and an optical sensor and connect them together, you can actually hear the flicker as a buzzing. And the interesting thing about that is the ear is very good about discriminating in a spectral sense. If you listen to these lamps, usually they'll have various hums and buzzes and different signatures, and it gives you an idea it gives you a very clear audio impression of what your eye and really what your brain is being exposed to, even if you can't directly perceive it. So I recommend those two techniques for making this measurement. One of the first things people ask me when I talk to them about flicker is, because we're all familiar with incandescent lighting as a sort of a standard, is how much does an incandescent lamp flicker? And the answer is it kind of depends on the construction of the filament, but somewhere between 3 and 6%. The typical A-line lamp is about 6%. And something with a heavier filament that can hold heat longer, like say a 12-volt MR16 sort of filament, it flickers less because it can retain the heat and glow longer after power is momentarily reduced. And as for fluorescent lamps, which we're all familiar with, there it varies a lot because a lot depends on the ballasting technology. So magnetic ballasts, they can have a substantial amount of flicker. The electronic ballasts, they can be really good or they can be all over the map because the electronic circuitry, again, as a function of the design trade-offs that were made when the ballast was designed, either cost or other considerations, can result in lighting that either has systematic 120 hertz type flicker or very high frequency flicker. Could be deep 40 kilohertz flicker. Now, biologically, it's not known that there's a big effect for really high frequency flicker, but if it's deep, there is definite, 50%, 30%, near 100%. There can be a profound effect on things like machinery and in some cases it can be a safety hazard, like around rotating machinery or cutting tools in a shop, etc. And as far as LEDs, they're actually capable of the worst sort of flicker because their responsivity in terms of time is the fastest of any of this technology. So it's never actually been a serious problem with incandescence in the sense that the fundamental technology helped eliminate or reduce the systematic flicker. But with LEDs, they can respond almost instantaneously. So the electronics has a very major effect on how that flicker translates. And John, I'm going to ask you to click to the next slide because I'm having a network connection problem and I'm no longer able to cycle the slides. So let's go to slide 15.
You just tell me what to do. We're there.
Okay. So I can't see it, but I'm assuming we're on slide 15. And what this is it's a side-by-side comparison of several of these light sources, as I mentioned. And you can see that the 60-watt A19 and the 35-watt MR halogen, they have, in relation to their output, that's on a 0 to 100% scale, a relatively small flicker. And the 25-watt self-ballasted metal halide next to it, the part 38, it has a low, in a sense, a low absolute flicker, but it's an extremely high frequency. It's a carry through from the electronics that's in the self-ballasted base of that lamp, and so that lamp would probably have the appearance of very even light, and may not have a profound direct effect biologically, but it would definitely have visible artifacts for rapidly moving things like Dremel tools or circular saws, etc. The fluorescent T12, you can see actually, and I believe that's a magnetically ballasted unit, but I can't quite read it on the slide from here.
It is. It is.
Yeah, that's got pretty deep flicker, and again, the electronic ballasts are probably going to resemble the self-ballasted trace a little bit more closely. And you can see the quad tube CFL there has a much better, flatter line, but there's still some 120 hertz ripple there coming through. Let's go to the next slide.
We're there.
Okay. So this is an example of what the trace looks like when you have 100% deep flicker. So I don't want to get too technical, but I can look at this trace and tell you exactly how the circuitry in this lamp works. It's probably a buck converter, meaning it's able to take a part of the line voltage and reduce it down, but not drive the LED all the way through the AC cycle. And so those are the areas where it drops out. and there's no capacitor or energy storage device inside this lamp that would sort of hold up the lamp in those regions where the power is cut out. So this is actually the worst case right here, and this is the kind of lamp that you really do want to avoid, unless you want it for some laboratory purpose where you want 120 hertz stroboscopic light, and sometimes there's a use for that, but definitely not in general lighting where you're trying to get anything done. And I think my network connection is back, so I'm going to try to go to the next slide. Yeah, I'm sorry, John. Go ahead.
I just wanted to say, well, you can go to the next slide. There was a note I noticed that says that several years ago, one of the folks installed fluorescent fixtures in the office that was incandescent, and one lady had a desk under a fixture, began complaining the first week that they made the change. They had to go back, and the point is the flicker was increasing. So even though the flicker may have gone from 5 or 6%, right, under incandescent, to maybe 20 or 30%, this person noticed the change and was uncomfortable with the change. So those lower levels have an impact. You don't have to go to 100% by any means to have an impact. And
definitely.
Some people.
Go ahead.
Right. Some people are very, very sensitive to light. We're mentioning, for example, scotopic sensitivity syndrome. That really is. It's really all about light sensitivity. It's a perceptual processing disorder, not really an optical problem. It's really about the brain's ability to process light properly, and having changes in light amplitude can, for folks who are particularly sensitive, for example, children and folks who are on the autistic scale or have special sensitivities like those with scotopic sensitivity syndrome, those people can be affected at very, very low light, a very, very low modulation level. All of the studies that have been done about where flicker impacts you really have been done on the normal population, because researchers haven't wanted to impact people, for example, those with epilepsy and who had optical sensitivity, with putting them into studies because it puts them at risk. So this is a reason that we decided that 0, which is sort of like the sun, in terms of modulation, is much better than any other number.
It's definitely the optimum in terms of quality, and there's no doubt about that. The insidious thing about flicker is that essentially it's difficult to see, and especially if you're looking for it. I have been able to detect 60 hertz flicker. I've done some experiments on this myself just to find out what I can see. I'm able to see 60 hertz flicker in my peripheral vision, but not if I look right at the light. And usually you do this with lights that aren't particularly bright. But it's really easy to spot this yourself if you have things like night lights that are LED and not incandescent, or some LED Christmas tree lights. This type of light is usually made in a way where it doesn't have the energy storage devices or device needed to even the light out. And so, like in the case of a Christmas tree, you can look at it and it looks nice and steady. But as you dart your gaze away from the tree, you see this cascade of blinking lights. Sometimes you see this on the freeway with taillights. And that's actually a really vivid demonstration of the fact that even if you modulate at a very high frequency, like 200 hertz or even a couple of thousand hertz, you will be, if the modulation is deep, you will be able to see that in cases where, and again, it doesn't even have to be that the lighting is moving fast. If your eye is moving fast past the lighting, you will definitely see it. please. Next slide. So the interesting thing about LEDs is because they are so reactive and they are kind of an advanced technology in the sense that we are able by formulating the construction of the LED to really fine-tune the output spectrum. Unlike a fluorescent, there aren't really narrow spectral peaks. You can construct a nice even spectral output and adjust it to be really high-quality lighting. So LEDs have the potential for producing extremely high quality of light, and many do. But what isn't immediately apparent is the degree of care that's put into the electronics that has to drive those LEDs and eliminate that flicker. So LEDs have great potential for wellness, but it's not just the LED. It's also everything that goes all the way back to the incoming power. It all has to be designed coherently to make sure that there is no modulation in the output. And this slide is basically showing a overhead lighting in a classroom, but and children, as you might imagine, have neurologies that are very quick, right? And they're able to see and process things more rapidly, and so the classroom is the ideal place to install flicker-free lighting. And I think there are cases actually where John, I think you and I were talking offline. I think you were telling me about a case where a school actually reverted back to incandescent lighting because of this. They noticed, not that they saw it, but they noticed a negative effect on the student body.
Yeah, again, these are kids who are special. This is a special needs classroom, and special needs kids often are more susceptible to whatever the lighting is. And having in fact, there are some cases, if you follow the literature, there's some cases where the children actually claim they can see the flicker. And at any rate, in order to create a calmer atmosphere, they changed them back to incandescent, which has, as we know, has relatively low flicker compared to any other conventional technology.
Yeah, it's completely. I completely believe it that children can see flicker, let's say, over a broader spectrum. I remember the old CRT days before LCD panels, and the backlights in LCD monitors, by the way, they also do have some flicker. Typically, they're dimmed by deep PWM, but the frequency is very high, and so it's not immediately noticeable. But the old CRTs, for those of you that remember those, they had screen refresh rates that could be anywhere from 30 to 60 hertz, and then eventually they got better and went to 100. But I remember very clearly, in even the television, which the old analog TV systems, they had about a 30 hertz screen refresh, and I clearly remember growing up and thinking to myself, why do they make it so this thing blinks like that? So I think children can definitely see it. When we started off the webinar, I briefly described what flicker is and isn't for the purposes of our talk today, but there's a lot of confusion about it. There are misconceptions. Some people think that LED lamps are inherently flicker-free or produce extremely even light because it's a newer technology. And as I mentioned, that really depends on the care and the quality of the electronics that's driving it. Another misconception is that as long as you can't actually see it, it won't really have an effect on you. It won't adversely affect cognition, headaches, etc. And that's just not the case. Yet another misconception is I don't have dimming lights, or I'm not dimming my lights, so they shouldn't be flickering. this is an understandable misconception because dimming technology, especially phase cut technology, triacs, the very common, what they do is they chop out part of the power line, and so they exacerbate and they make larger the power line fluctuations, the gaps where there's no power. They magnify that gap quite a bit, and so in a light that flickers less, when you dim it on a phase cut dimmer, it can actually increase the amount of flicker. But it doesn't totally go away unless the lamp is designed to be flicker free when working with a dimmer. So it's usually the case that if there's some flicker there, you'll get even more when you dim it. And then another question that I get frequently is what's the relationship between flicker and frequency? Because often you talk about flicker in terms of hertz, but it's not always a function of the power line. There could be other artifacts of the driving electronics that give you flicker at other frequencies. So as an example here, on the left we have a picture that's taken under a lamp with no flicker, and the shutter is open long enough to capture some of the motion, and you see it. The ruler there, it blurs, but it's pretty much smooth. The exposure is smooth, and then under a lamp that does have flicker, you get this very clear stroboscopic effect. Now these are still photos, but you can do this yourself if you happen to have a ruler or a pencil. If I don't use the camera, the slow motion camera trick, I usually look for deep flicker just by picking up a pencil or a ruler and doing exactly what you see here. And if the lighting has flicker on the order of more than 30%, it'll look just like this picture here. So this is the easiest way to detect it. On a slightly more technical level, the IEEE has produced a curve, or let's say a chart that shows the results of analysis that they've done, where they have separated the flicker into regions of, the white region is what I would call a region of unacceptable flicker. The yellow zone is a low risk area, risk in terms of health effects, and the green zone is the no observable effects area. And the little circles there represent actual measurements on energy-focused products, all one product, right? So all of our products have essentially the same near zero, less than 1% flicker specs. But the question is, well, what is the actual flicker measurement at, say, 30 hertz, or 90 hertz, or 120, or 800? And so these are actual data points from the energy-focused products, where you can see in the areas where the susceptibility or the effect, the biological effect, is the highest in that 10 to 100 hertz, or actually even up from 1 hertz. 1 to 10 hertz is blatantly visible, but even from 10 to 100, where the eye starts to average it in your direct line of sight, our products have substantially less than 1% flicker. They're in the 0.1% range, and as John mentioned, that starts to get into the detectability of the measurement device, actually. So I think it's fair to say that energy focus says less than 1%, but the reality is we are essentially driving our LEDs with DC flicker-free current up until you get into the power line range, and it's very important to do that in the 1 to 100 hertz range, because, as I say, the lower the frequency, the more palpable and direct is the biological effect. So what can be done about it? Well, in a nutshell, the electronic package that actually drives the LEDs must be designed in a way to deliberately eliminate flicker over a broad wavelength range. As I said, as I showed a moment ago on that chart, It's not just about the 120 hertz or the 100 hertz about from your power grid. Any kind of nonlinear operation, and power supplies are extremely nonlinear. Anything that takes the sine wave power coming in and operates on it in a way that isn't linear is going to produce harmonics or essentially flicker at higher and even lower frequencies than the 120. So you really need to design your electronics in a way where it completely filters all of that out. And Energy Focus has done that. Here's an actual lab measurement with or without and then with our flicker elimination technology. And you can see in the scope traces on the right, the traces are essentially flat. Other than the health effects, it is worth noting that flicker can have a bad effect on machinery, especially the very high frequency flicker. So, as an example, if you just take a bare set of LEDs and attach it to a high frequency ballast that, let's say, originally was designed for fluorescent lighting, that ballast typically has a very substantial high frequency content, maybe 70 kilohertz, 40 kilohertz, definitely something you wouldn't see, and definitely something which the phosphors of the glass fluorescent tube technology can sort of filter a little bit, the low pass filter somewhat. But the LEDs respond almost instantly, and so when you attach LEDs, you're going to get the full high frequency output of that, and it can go straight into an optical scanning device and totally confuse the circuitry. John, we were talking about this too. What was that situation where the LEDs that got installed in a retrofit situation, but they kept the old ballast? Right, and it had a really bad effect on the scanning equipment. Tell us a little bit about what happened there.
Exactly. As you said, the fluorescent lights, the discharge actually stays running at those high frequencies, and the light continues on. But for LEDs, they can follow the 70 kilohertz or 100 kilohertz or whatever it is frequency, and that light pulses on and off at that frequency, and in fact screws up the scanners. It was so bad that they couldn't sell groceries after having improved the lighting. So fortunately, we were able to help them out because we make a product that'll work off of existing ballast too, so there was no real problem with that. But we put in the required energy storage so that at those frequencies, so that there was basically no flicker. And you could and no impact therefore on making a sale, which was kind of important to the folks in the store. But this is a real, paying attention to it.
Let me just add, John, that not only do we add the energy storage, but we also install the flicker elimination technology, even on those lights that are running off a backward compatible attached to a fluorescent ballast. So with Energy Focus retrofit products, you get flicker-free output regardless of how you do the installation.
Right.
Okay, and so we're nearing the end of our technical summary, but basically the important thing to take away is this. LEDs are the advanced lighting technology that's here to stay. I won't even say of the future because they're here now, but they do have characteristics that require the design of the supporting electronics to meet a higher standard than they do for older technologies. In the case of incandescent, there really wasn't an electronics package, but by the physics of it, the flicker wasn't really severe. But now these more fluorescent was worse, but now LEDs are so responsive that it's absolutely necessary to eliminate flicker as a design measure from the very beginning. And Energy Focus does that. So, and one thing to look for, and you'll see this on the marking for all of our products, is third-party verification of the flicker level. So we don't just stamp our products and say less than 1% because we've measured it in the lab. We get third-party, in this case UL, verification, and they certify that they've made this measurement, and these are the numbers we use. We don't use our own measurements, which agree with UL, but we mark our products based on third-party verification, and we would encourage anybody who cares about flicker or is concerned about it to look for this kind of mark. And so, Yumi, I'm going to turn it back to you because I think we have another poll, and then
yep, we do.
Basically the Q&A after this.
Yep, that's correct. So to everyone in the audience, we would just like to know, does UL Flicker verification have value to your organization? Flicker UL verification is a new third-party verification. We are very excited about it, and we took part in it right away. We were actually the first U.S. LED manufacturer that got a UL approval. So we find this as very important. So we want to throw this question out to the audience. I do see a lot of results coming in. I'll give it a couple more seconds. Okay, I am going to go ahead and close this poll. And after I do close this poll, you will see that a very healthy percentage, 85.2% of this audience thinks that yes, this UL Flicker verification does hold value to their organization. This is very, very helpful for us, so thank you for participating. Hopefully you'll see the list of manufacturers grow who do take part in this UL Flicker verification. To continue on, the next part of this agenda is the Q&A session. And Laszlo and John, while you were going through the slides and the comments, there were a lot of questions that came in. I am taking a look at the time, so I will be selective of the questions that I'm presenting here. The first question has come from Edward. Edward has asked, how will the upcoming DLC QPL 4.3 that includes the flicker standard, which is based off of the IEEE recommendations, impact all LED standards? And I guess that is in our point of view. So again, the question was, how will the upcoming DLC QPL 4.3 standards that include a flicker standard impact all LED standards?
Well, yeah, there's no doubt. Yeah, go ahead, John.
I was going to say that the chart basically that Laszlo showed basically would allow you, suggest that in order to be compliant, right, you would want to be in the green region